Epoxy is known for its strong adhesive qualities. It can be used with various materials such as wood, fabric, glass, china, and metal. It can be flexible or rigid and can be opaque or translucent. It has high strength and low shrinkage. It can be used for the construction of vehicles, snowboards, aircrafts, but also can be used for arts and crafts and ceiling floors and countertops. Epoxy alone is not conductive, but when it is combined with silver-filled epoxy, it becomes conductive. The most common type is silver, but gold, nickel, copper, and carbon can also be used. It can be oriented in the magnetic field for its molecule structure, having larger magnetic susceptibility and anisotropy. It can also maintain the orientation through cross-linking in the magnetic field. Epoxy is corrosion resistant. Its properties can make it resistant to most chemicals. It is very resistant to alkali, which is important in surface treating concrete. They have optical properties such as light transmission at various wavelengths. Light transmission values from 200 nanometers up to 5 micrometers. The melting point of epoxy is 140 degrees Fahrenheit. The thermal conductivity of epoxy is 0.15 to 0.25 watt per meter per Kelvin. The thermal expansion of epoxy is 45. Compression strength is from 500 to 12,000 psi. The hardness is 83. The tensile strength is 7,846 psi. The compressive yield is 11,418 psi.
Prepregs. Pre-impregnated materials are utilized in high-performance applications when weight and mechanical properties are top priority. Manufacturers from the aerospace, transportation, and sustainable energy industries benefit from impregnated material properties. Prepreg chemical properties. Prepregs are corrosion resistant and can tolerate lots of different conditions. Pre-impregnated structures provide aerospace and aviation manufacturers the opportunity to reduce weight, increase strength, and increase environmental corrosion resistance in the areas needed. Prepregs can withstand harsh circumstances without corroding or reacting poorly. However, the precautions commonly to be taken for the storage of prepregs by themselves is to keep them away from direct exposure to sunlight, heat, moisture, and any chemicals, as these factors will have deteriorating effects on the ballistic performance. The surface tension of prepregs is 44 to 48 mN per m. The present invention provides a backing sheet that has been surface treated to increase its surface tension on the side in contact with the prepreg. Prepreg electrical and magnetic properties. Prepregs are thermally and electrically conductive. Prepregs often use dielectric material applying some metallic fibers. Thermally and electrically conductive prepreg material cooperates fibers constructed of a dielectric material. Thereafter, combining the bundles with fibers with those that contain metallic surface coating, a web forms so that the bundles extend over the full surface area of the web, and contacting individual fibers of the bundle as well as the bundles with a curable, uncured resin. A magnetic prepreg is formed by impregnating a magnetic paint composed of soft magnetic powder, which is essentially metal and flat. When the powder is impregnated in said prepreg, it's oriented in a surface direction. Magnetic prepregs impregnated with magnetic powder. As you can see in the diagram to the side, it shows the magnetic assisted composite manufacturing that incorporates the use of prepregs and a magnetic sheet, which is similar to the use of the metal powder in certain prepregs. Prepreg thermal properties. The melting point of prepregs are generally between 25 degrees Celsius and 100 degrees Celsius. Prepregs are very thermally conductive and can function well under a very wide range of temperatures, especially when being mixed with other conductive materials. Prepregs thermal conductivity is 0.23 W per mK, which is increased to 0.36 W per mK by the incorporation of carbon fibers. The thermal expansion of prepregs is 35 to 57 nanometers per meters degrees Celsius. The results for the coefficient of thermal expansion were obtained in three principal directions using a thermomechanical analyzer. The coefficient of thermal expansion was independent of the temperature ramp rate. Prepreg mechanical properties. For the mechanical properties of prepregs, I'm going to begin with the two more simple characteristics. The surface hardness of prepregs are RM11.3, and the tensile strength of prepregs is 600 MPa. The compression strength of a prepreg is 1320 MPa, which you can determine using the DIN-EN ISO 14126 method. A prepreg with good drape properties can be described as ductile. Ductile composite prepregs should have high flammability. Fracture was determined at 90% and 80% of the max breaking load. Fatigue tests were performed by cyclic bending loads during a three-point arrangement on a universal servo-hydraulic testing machine.
Polyvinyl chloride, or PVC, is one of the most used produced plastic polymers in the world. It is actually the third most used in the world. It is a solid plastic material made from vinyl chloride. PVC comes in two basic forms, flexible or rigid. Vinyl is very versatile. It can be thin and flexible or rigid and strong. It can also be colorful or completely clear, so when you're constructing something or building something, you can fit to your liking. It is used for a variety of different things, including buildings and constructions, healthcare constructions, etc. It is normally used to make pipes, medical devices, flooring and siding. Thermal properties of PVC. The melting point of PVC is 100 degrees Celsius to 200 degrees Celsius. Thermal conductivity is 0.19 and thermal expansion is 0.28. When PVC reaches its melting or boiling point or starts to burn, it can export toxic fumes into the air, which is not good for the environment. One benefit about PVC and PVC pipes especially is that unlike metal, it won't rust or corrode as easily because it doesn't react with water and air the same way that metal does. So in the long run, PVC pipes will last a lot longer, which is very beneficial for when you're building houses, constructions, like metal equipment, things like that. PVC also does not react to alcohols, fats, oils, or aromatic free petrol. It also is resistant to most acids and alkalides and salts. The surface tension of PVC is 40. Electrical properties of PVC. PVC has good insulating properties, but the electrical losses in the material are sufficiently high so as to permit high-frequency welding. Other electrical properties and magnetic properties of PVC include the conductivity is 0.4 to 0.28, and PVC does not hold heat very well, so it's not that great of a conductor. And there are magnetic PVC pipes.
Pros and cons. Pros of PVC: can be cut, shaped, and formed easily, good mechanical strength and toughness, lightweight, durable, easy to install, cost effective. Cons of PVC: poor heat stability, can emit toxic fumes when melted. Pros of epoxy: It has strong adhesive qualities. It has high strength. It is corrosion resistant and has low shrinkage. Cons of epoxy. It is not conductive alone. Pros of prepregs. Prepregs make better cosmetics, less mess, waste, and curing time. Prepregs contain 35% resin, better comforty, and quality, good fatigue resistance. Cons of prepregs. Poor shelf life, has to be kept cool to last longer, and the necessary heat cure of prepregs. Industrial and consumer applications of our materials. PVC pipes are industrial applications for PVC. Credit cards, furniture, clothing, shoes, bags, sports equipment are all consumer products for PVC. Floor coating is an example of an industrial application for epoxy. Paint, coatings, sealers, adhesives, and plastics are all examples of consumer products for epoxy. Hand layup and vacuum bagging are industrial uses for prepreg. Aerospace, racing, sporting goods, pressure vessels, and commercial products are all consumer products of prepregs.